Okay, so we're on page 61, and this is how this is going to work. So you're going to try each problem, and then you're going to unpause the video and go back and then listen to the directions and make sure that what you did on your paper matches the correct process. So now you're going to pause the video, and when you're done with number 1, press play. Okay, so let's look at number 1. The key verb here is to verify and inverses. So to verify if two things are inverses, we have to do f of g of x, and it has to equal x, and you have to do g of f of x, and that also has to equal x. And if that happens, then they are verified to be inverses. So first let's do my f of g of x, which means I'm going to have f of x plus 1 over 4, which means I'm going to have 4 times x plus 1 over 4 minus 1. So if you look at this, when you multiply by 4 and divide by 4, they're going to undo each other. So now you're left with x plus 1 minus 1. And plus 1 minus 1 undo each other, leaving you with just x, which is what we wanted. Okay, now we're going to do g of f of x, which needs to be g of 4x minus 1, which means I'm going to have 4x minus 1 plus 1 all over 4. Okay, now if you look at this, the minus 1 and plus 1 undo each other, leaving you with just 4x over 4. And when you multiply by 4 and then divide by 4, those undo each other, leaving you with just x. And now, congratulations, you have verified it. So now pause this video and go back and try number 2. Okay, so now we have two functions again, and first thing I'll talk about is this. This is just a restriction, and it's here because we want to make sure that everything we were plugging in works out nice and pretty, so don't worry about it being there. It's just kind of like along for the ride. So now again, we're going to do our f of g of x, and if these are inverses, I should get x. So that means I'm going to do f of x squared minus 3, which means you're going to have the square root of x squared minus 3 plus 3. The minus 3 and the plus 3 cancel off, so now you're left with the square root of x squared, and the square root of x squared is simply just x. Now remember, you're not done. You have to do f of g of x, and now we have to do g of f of x. If you don't do the second piece, it's like you only did half the problem and you won't get all the points. So g of f of x means g of the square root of x plus 3. So that means I'm going to have the square root of x squared. Oops, nope, sorry, not x squared. So I can erase that. Oh, it's not going to let me. Okay, let me cross that off. Oh, man. Let's try that one more time. Cross that off. Means I'm going to have the square root of x plus 3 squared minus 3. Well, a square and a square root undo each other, so now you just have x plus 3 minus 3. And the plus 3 and minus 3 undo each other, leaving you with just x. And again, you have verified it because g of f of x equals x, and f of g of x equals x. Now you're going to go try number 3 and come back to the video and make sure you did it right. Okay, number 3 is different because the directions say to find the inverse algebraically. So to find an inverse, remember we just talked about on the previous page that we switch x and y, and then we resolve for y. So I'm going to rewrite this as y equals negative 4x minus 9, and f of x and y, they're synonyms, so we haven't really done anything yet. Now I'm going to switch my x and y. So x equals negative 4 y, and I'm going to put a negative 1 right here because it's y inverse that we're solving for. If you forget this negative 1 power, you're not really telling us that you're finding the inverse. And then minus 9. And now we just have to get this y thing by itself. So I'm going to add 9 to both sides, which gets me my x plus 9 equals negative 4 times y inverse. And then we're just going to divide by a -4, divide by a -4, which is going to take me up here to my final answer. X plus 9 over -4 equals my y inverse. Okay, now pause the video again and try number 4 and come back and see if you got it right. Okay, so number 4 is algebraically pretty much as hard as it can get. So remember, we're going to switch x and y. So I'm going to have x equals y inverse plus 3 over y inverse minus 2. Okay, so I need to get the y by itself. So the first thing I'm going to do is I'm going to multiply both sides by this y inverse minus 2. And if I do it on one side, remember you have to do it on the other. Well, in doing so, this will cancel off on this side, but on this side you will be left with a y inverse minus 2 times the x you had, and on the other side you're left with your numerator, which is y inverse plus 3. I'm going to distribute this x in, so I'm going to have x y inverse minus 2x equals y inverse plus 3. Okay, and I know that you're looking at this and you're like, okay, I don't know what to do next. Well, here's the trick. You need to put the y inverse stuff on the same side. So I'm going to move this y inverse over to the other side. And at the same time, I'm going to add my 2x to the other side. And the reason I'm doing this is because I want to put all the y inverse stuff on one side and then not y inverse stuff on the other side. And I'm going to add a new screen so I have some more space to it. So when you do that, you're going to have x y inverse minus a y inverse equals 3 plus 2x. And one of your favorite math F words is to factor. These both have a y inverse. So I'm going to pull out my y inverse. I'm going to be left with x and a minus 1. Please do not forget there's an invisible 1 right there, so when you pull the y inverse out, there's a 1 still left over. And then this equals my 3 plus 2x. And now I'm going to simply divide by x minus 1 because I want to get the y inverse by itself. So your final answer is that your y inverse, or your inverse function, is going to be 3 plus 2x over x minus 1. That one was pretty tricky. Okay, now we're going to look at number 5, and I want you not to pause the video this time. I just want you to look at number 5 with me because it is very, very tricky. Okay, so number 5 says, try finding the equation of this inverse function using any method. Tricky. It's a bonus worthy. Okay, well, let's look at this for a second. I hope you remember from Algebra 2 that absolute value function is going to make a v. And that minus 2 moved it to the right 2, so 1, 2. So your v is going to look something like that. So if you were to put some dots, and I apologize ahead of him because drawing on my iPad is not the easiest thing to do, but if you were to put some dots on here, this first dot down here would be 2, 0, and then you would have right here, you would have 1, 1, and then over here, you're going to have 3, 1. Okay, well, so if you think about it for a second, finding an inverse, all you have to do is you have to switch the x and y, or switch the ordered pair. So I want to draw, and I'm going to draw a little bit bigger this time. So I'm going to switch my ordered pairs. So instead of having 2, 0, I'm going to go ahead and graph 0, 2. Right there. And instead of graphing 3, 1, I am going to graph 1, 3. And instead of graphing 1, 1, well, when you flip 1, 1, it's still 1, 1, so 1, 1, like that. And now you can see I have this inverse function right, oh, well, maybe if I could draw through my point, but there's my inverse function. And this piece right here is super important. It says x has to be bigger than or equal to 2, because right here, if I go back here, I'm going to color in blue for a second. X has to be bigger than or equal to 2 means I only wanted this piece right here. Well, if you only want that piece, then that means I never should have graphed this 1, 1 side. I only should have graphed this side. And this blue thing that I just colored in, it is just a line. And I know that you can write the equation of a line. So under the equation of this line, it has a y-intercept of 2 and a slope of 1. So I would say that y equals, my slope is 1, so x plus 2. And remember, we need to keep our restriction with us, but this was an x restriction. So when we plugged in the 2, I take my 2 right here and I plug it into this function, y is going to be 0. So down here, we're going to put that x has to be greater than or equal to 0. Because remember, the domain becomes the range and the range becomes the domain. Well, when you have this right here, this domain, it also was hiding from you that meant y was going to be greater than or equal to 0. That was on the original function. When we go right here to this one, our inverse, the domain becomes the range. So these x's become the y's, and the y's become the x's. So this y becomes that x. And this, my friends, is your final answer.